飞车的历史、现状与未来。飞车作为一个迷人的概念，长期以来吸引着人类的想象力，象征着科技突破了地面与天空的界限。本文将对飞车的发展历程进行全面回顾，探讨其历史、现状以及未来展望。1、历史背景。飞车的构想可以追溯到20世纪初，早在汽车和飞机问世之前，人们就对能够同时在地面和空中行驶的交通工具充满幻想。飞行的交通工具在许多神话和文学作品中频频出现，如飞毯和神奇的战车等。文艺复兴时期，达芬奇设计了空中螺旋桨，被视为早期飞行器的先驱。1900年代、1950年代。1917年，格伦·库尔蒂斯展示了自动飞行器，被认为是首个飞车的雏形。1937年，沃尔多·沃特曼推出了 Aerobile， 具备可拆卸的机翼，能够在地面和空中切换。1946年，罗伯特·富尔顿设计了 Amphibian， 可在飞机和汽车之间快速转换。1960年代、1980年代。这一时期是飞车发展的重要阶段，受到了太空探索和个人航空的启发。1960年代，飞车的概念因太空竞赛而受到关注，许多人相信个人飞行是可行的。1973年 ，Avenue Mizar 项目将福特皮拖车与塞斯纳飞机结合，但因试飞失败而终止。1980年代，保罗·莫勒博士致力于开发 Skycar。虽然它具有垂直起降能力，但始终未能商业化。1990年代、2010年代，随着技术的进步，飞车的实现变得愈加可行。2009年 ，Terrafugia Transition 推出，成为首个获批的可在公路和空中使用的飞车。2010年代 ，AeroMobil 和 PLV 等公司开始推出工作原型，专注于安全性和法规合规。2、当前状况与未来展望。进入2020年代，飞车技术迎来新的发展高潮，电动垂直起降 eVTOL 飞机成为主流。2020年代初 ，Uber 和现代等公司积极投资 eVTOL 项目，旨在实现空中共享出行。人工智能的引入将提升飞车的操作安全性和效率，预计将减少人为失误并优化交通管理。城市基础设施如 Vertiports 的建设也在进行中，以适应新型交通工具的需求。3、飞车的共同点与差异。所有来源均强调飞车的历史根源和技术演变，展现了人类对飞行梦想的持久追求。然而，不同来源对个别事件的细节和影响有不同的强调。例如，有的来源侧重于个人故事和早期设计的实际应用，而有的更注重历史的系统性演变，还有的则探讨了飞车作为科技进步的象征。4、结论。飞车的发展历程是人类创新精神的体现。从早期的实验到如今的实际应用，飞车的未来充满希望。随着技术的不断进步和商业化的日益临近，飞车或将成为日常生活的一部分，真正实现飞行的梦想。各来源总结。来源1 Flymos/Flymo Ord Blog 201902 Fly in Cars Past Present Future。 该来源详细记录了飞车的历史，从格伦·库尔蒂斯的自动飞行器到现代的 PLV 等，强调了飞车作为个人交通工具的实用性和发展潜力。文章指出，尽管飞车的实现面临许多挑战，但21世纪的技术进步为飞车的商业化铺平了道路。来源 L Flying Car Insiders/Flying Car Insider Com Blog The Evolution of Flying Cars A Historical Perspective。 这篇文章追溯了飞车的历史，强调了早期的创新和实验。他提到，飞车的概念不仅是科技的产物，也是人类对飞行梦想的追求，展示了从古代神话到现代科技的演变过程。来源 The reignited/www.thereignited.com 202405 07 Tech Fly in Car Technology History Future。该来源探讨了飞车概念的象征意义，强调了它作为技术进步的代表。文章指出，尽管飞车技术尚未完全实现，但随着科技的发展，飞车的未来可能比我们想象的更近。飞车的历史和未来展望清晰地表明，人类对飞行的渴望与日俱增。随着技术的不断进步，飞车即将迎来属于它的时代，成为我们生活中不可或缺的一部分。
The topic of flying cars encompasses a fascinating historical trajectory and an intriguing future, blending imaginative aspirations with technological advancements. Here are some counterintuitive insights derived from the discussions surrounding the history, present, and future of flying cars. Historical context. 1. Myth versus reality. The concept of flying cars dates back centuries, often rooted in mythology and literature long before the advent of actual technology. This raises the question, did human imagination outpace technological feasibility? While many technological predictions from the past have come to fruition, the flying car remains an elusive dream, reflecting not just a failure of innovation but also a profound cultural yearning for transcendence over earthly limits. 2. Early failures and innovations. Early attempts to create flying cars, such as Glenn Curtis's Autoplane and Waldo Waterman's Aerobile, often failed to achieve practical functionality. However, these failures were pivotal. They laid the groundwork for future innovations. The paradox is that sometimes failure can be more informative than success in the field of innovation, as each iteration provided invaluable lessons about the complexities of merging aviation and automotive technologies. Technological development. 3. Inherent complexity. The technical challenges of building a vehicle that can operate safely and efficiently in both air and on the road are immense. The counterintuitive realization here is that while we have made significant advancements in both aviation and automotive technology, combining these two domains has proven to be extraordinarily complex, resulting in many promising designs remaining uncommercialized. 4. The role of regulation. One might assume that technological feasibility would be the primary hurdle to the widespread adoption of flying cars. However, regulatory frameworks often pose a more significant challenge. The intricacies of air traffic control, safety standards, and road regulations create a landscape where even the most advanced technology struggles to gain acceptance. This suggests that societal and regulatory acceptance can lag behind technological capability. Current status and future prospects. 5. Electric vertical takeoff and landing eVTOL. The current shift towards eVTOL vehicles represents a counterintuitive pivot in the flying car narrative. While flying cars have traditionally been envisioned as hybrid vehicles, the focus on electric-powered designs indicates a move away from conventional automotive paradigms. This redefinition of what a flying car can be reflects a broader trend in transportation towards sustainability and environmental consciousness, which was not a primary consideration in earlier designs. 6. Cultural symbolism. The flying car has often served as a symbol of disappointment in technological progress. This notion is counterintuitive when considering the rapid advancements in other areas of technology that have reshaped our lives. The disparity between expectations surrounding flying cars and the reality of current technological capabilities illustrates a broader societal issue: the disconnect between aspiration and practical application in the realm of innovation. 7. Public perception and acceptance. Despite the excitement surrounding flying cars, public perception remains skeptical. Many people associate flying cars with science fiction rather than reality, which complicates efforts for adoption. The counterintuitive aspect here is that while technology may be nearing readiness, societal attitudes and fears about safety and practicality could hinder their integration into everyday life. 8. Infrastructure challenges. The concept of vertiports for eVTOLs is emerging as a necessary infrastructure component for the future of flying cars. However, this raises the counterintuitive conclusion that while flying cars may become technologically viable, the infrastructure to support them may lag significantly behind, posing yet another barrier to their widespread adoption. Conclusion. The journey of flying cars is a rich tapestry of human aspiration, technological experimentation, and societal challenges. It reveals a counterintuitive reality. While we stand on the brink of potentially realizing the flying car dream, numerous factors, cultural, regulatory, infrastructural, continue to shape this narrative, often in unexpected ways. As we look forward to the future, the interplay between technology and society will remain critical in determining whether flying cars can transition from a long-held dream to a common reality. Overlooked aspects of flying car development, significance and implications. The evolution of flying cars, often regarded as a symbol of futuristic innovation, encapsulates a rich tapestry of human ingenuity, ambition, and the ever-present struggle against the constraints of conventional transportation. While many reports highlight the milestones in the development of flying cars, certain critical aspects tend to be overlooked, yet they carry significant implications for the future of personal and public transportation. Below are key overlooked elements within the narrative of flying car history and their significance. 1. The role of early innovators and their contributions. Many accounts of flying car development tend to focus on well-known prototypes in contemporary companies, often glossing over the contributions of early innovators like Glenn Curtiss and Waldo Waterman. Curtiss's 1917 Autoplane was one of the first attempts to merge automobile and aeronautical technology. Waterman's Aerobile in 1937 introduced detachable wings, a pioneering concept that predated many modern designs. Significance: understanding the foundational technologies and concepts introduced by these early inventors offers valuable insight into how innovation builds on past ideas. Their experiences illuminate the iterative nature of technological advancement, emphasizing that today's flying cars are not just products of contemporary engineering but are deeply rooted in a century of experimentation and vision. 2. Societal and cultural influences. The evolution of flying cars has been influenced significantly by societal expectations and cultural narratives. The portrayal of flying cars in mid-20th century media, such as the Jetsons, shaped public perception and expectation of personal aerial transportation. This cultural backdrop created a desire for innovation that often outpaced technological readiness. Significance: recognizing the impact of societal narratives helps us understand why flying cars have remained a compelling dream rather than a realized technology. This intersection of technology and culture demonstrates the importance of aligning technological development with societal readiness, regulatory frameworks, and public acceptance. 3. Regulatory challenges and airspace management. The technological development of flying cars is not just about creating new vehicles, it also involves navigating complex regulatory landscapes. The introduction of flying cars necessitates a re-evaluation of existing air traffic management and safety protocols which are currently designed for traditional aviation. Significance: the complexities of integrating flying cars into existing airspace highlight the need for innovative regulatory approaches and infrastructure development such as vertiports. Understanding these regulatory challenges is crucial for stakeholders as they develop systems to support flying cars, ensuring safety and efficiency in urban air mobility. 4. Technological interdependencies. Flying cars rely on a convergence of various technologies including electric propulsion, AI, and advanced materials. For instance, the recent interest in electric vertical takeoff and landing eVTOL aircraft is not merely a trend but a response to the dual challenges of urbanization and environmental sustainability. The advent of lightweight materials and electric propulsion systems is essential for creating viable flying cars that can safely operate in urban environments. Significance: acknowledging these technological interdependencies is crucial for fostering innovation. It highlights the collaborative nature of modern technological advancement, emphasizing that breakthroughs in one area can catalyze advancements in others, further propelling the development of flying cars. 5. Economic implications and market viability. While many reports discuss the technical feasibility of flying cars, the economic implications often receive less attention. The market viability of flying cars will depend not only on technological advancements but also on consumer acceptance, pricing strategies, and the creation of relevant business models. Companies like Uber and Hyundai are exploring aerial ride-sharing services. But the economic success of these ventures hinges on public willingness to adopt such modes of transport. Significance: understanding the economic landscape surrounding flying cars is essential for potential investors and developers. It underscores the necessity of conducting market research and developing strategies that align with consumer behavior and urban mobility trends, ensuring that flying cars transition from novelty to necessity. 6. Environmental considerations. The environmental impact of flying cars is another often overlooked aspect. As air traffic increases, concerns about noise pollution, energy consumption, and emissions become paramount. The development of eVTOLs, which promise to be more environmentally friendly than traditional aircraft, highlights the industry's potential to contribute positively to urban mobility. Significance: addressing environmental considerations from the outset can enhance the credibility of flying car technologies. It underscores the importance of integrating sustainability into the design and operation of flying cars. Aligning with global efforts to combat climate change and promote eco-friendly transportation alternatives. 7. The psychological impact of flying cars. The psychological implications of flying cars, how they affect public perception and individual behaviors, are rarely discussed. The introduction of flying cars could alter urban landscapes and personal mobility experiences, impacting how individuals perceive travel and transportation. Significance: understanding the psychological aspect of flying car adoption can inform marketing strategies and public policy. It encourages stakeholders to consider how flying cars might redefine personal space, community structure, and even socioeconomic interactions within urban environments. Conclusion: the narrative surrounding flying cars is rich and multifaceted, extending beyond mere technological advancements. Recognizing the overlooked aspects, such as the contributions of early innovators, societal and cultural influences, regulatory challenges, technological interdependencies, economic implications, environmental considerations, and psychological impacts, enables a more comprehensive understanding of the flying car phenomenon. As we stand on the brink of this transformative technology, embracing these elements will be crucial for realizing the dream of flying cars and ensuring their successful integration into our daily lives. In-depth analysis and discussion of flying cars, past, present, and future. 1. Historical context and evolution of the concept of flying cars. The notion of flying cars has deep historical roots dating back to ancient mythology and literature, where the idea of vehicles capable of traversing both land and air has been a source of fascination. Leonardo da Vinci's sketches of aerial devices in the 15th century and the literary works of Jules Verne in the 19th century reflect humanity's enduring desire to conquer the skies. The 20th century marked significant milestones in the development of flying cars. Initiated by pioneers like Glenn Curtiss with his Autoplane in 1917 and Waldo Waterman's Aerobile in 1937. These early attempts laid the groundwork for future innovations, showcasing a blend of automotive and aeronautical engineering. Despite numerous prototypes such as the Avenue Mizar and Paul Mahler's Skycar, many projects face technical and regulatory hurdles, underscoring the complexities of creating a viable flying vehicle. 2. Technological advancements and challenges. The evolution of technology has played a critical role in the progress of flying cars, particularly in the late 20th and early 21st centuries. Breakthroughs in materials science, propulsion systems, and computer-aided design have made flying cars more feasible than ever. The introduction of electric vertical takeoff and landing eVTOL vehicles signifies a transformative shift, with companies like Terrafugia, AeroMobil, and PALV leading the charge toward practical flying cars. However, challenges remain, including regulatory compliance, safety standards, and public perception. which have historically impeded the widespread adoption of flying vehicles. The integration of artificial intelligence is poised to enhance operational safety, optimize traffic management, and reduce human error, making flying cars a more viable option for urban mobility. Ensuring that these technologies can coexist with existing transportation infrastructure is a crucial step toward their realization. 3. Cultural symbolism and societal implications. Flying cars have often served as symbols of futuristic aspirations and technological progress, embodying the dreams of a more convenient and liberated mode of transportation. They evoke a sense of nostalgia for the optimism of mid-20th century science fiction where flying vehicles were commonplace. However, the persistent absence of flying cars in everyday life has led to a cultural narrative of disappointment, raising questions about the pace of innovation in the physical realm compared to the rapid advancements in the digital space. This dichotomy reflects broader societal expectations regarding technology and its role in shaping our lives. As flying cars inch closer to reality, their societal implications warrant careful consideration. Issues such as urban air traffic management, environmental impacts, and accessibility will play critical roles in determining how flying cars fit into the transportation landscape and whether they enhance or complicate urban living. 4. Future outlook and potential integration into daily life. The 2020s are poised to be a pivotal decade for flying cars, with advancements in eVTOL technology and significant investments from major corporations signaling a transition toward commercialization. Companies like Uber are exploring air mobility networks, indicating a shift in how urban transportation may be conceptualized in the near future. The development of infrastructure such as vertiports will be essential for the successful integration of flying cars into urban environments, necessitating collaboration between governments, private sector stakeholders, and communities. Looking ahead, the potential for flying cars to alleviate traffic congestion, reduce commute times, and provide new forms of transportation is promising. However, realizing this vision will require addressing regulatory challenges, fostering public acceptance, and ensuring that technological advancements align with societal needs and values. The future of flying cars may not only redefine personal transportation but also reshape urban planning and community dynamics. These 4 points encapsulate the rich history, technological evolution, cultural significance, and future potential of flying cars, providing a comprehensive foundation for further analysis and discussion on this captivating topic. 1. The Curtiss Autoplane, 1917, created by aviation pioneer Glenn Curtiss. The Curtiss Autoplane was one of the earliest attempts to combine an automobile with an aircraft. It featured a car body with wings and was designed to take off and land like a plane. Although it only achieved brief hops and never saw true flight, it laid the groundwork for future flying car concepts. 2. The Aerobile, 1937, invented by Waldo Waterman. The Aerobile was one of the first functional prototypes of a flying car. It had detachable wings that could be removed for ground use, allowing it to operate both as a car and an airplane. The Aerobile represented significant advancements in multi-use vehicle design, showcasing the potential for dual-mode transportation. 3. The Mahler Skycar, 1980s to 2000s, developed by Dr. Paul Mahler. The Mahler Skycar aimed to revolutionize personal transport with its vertical takeoff and landing VTOL capabilities. Despite generating significant interest and media attention, the Skycar faced numerous technological and regulatory challenges, ultimately remaining in the prototype stage and exemplifying the difficulties faced in bringing flying cars to market. The future outlook of flying cars, predictions for 2030 and beyond. As we gaze into the future of flying cars, we stand on the brink of a transformative era in personal transportation. With more than a century of experimentation and innovation behind us, advancements in technology, infrastructure, and regulatory frameworks are converging to make the dream of flying cars a tangible reality. Here are some key predictions for the future of flying cars by 2030 and beyond. 1. Mainstream adoption of eVTOLs. By 2030, electric vertical takeoff and landing eVTOL vehicles are expected to become a common sight in urban areas. Major cities worldwide will likely witness the deployment of commercial flying taxis, offering on-demand air transportation solutions. Companies like Uber and Volocopter are already testing their eVTOL prototypes, and with the backing of significant investments they are on track to launch services that will allow passengers to book short flights over congested urban traffic. 2. Regulatory frameworks and air traffic management. For flying cars to become a viable mode of transportation, robust regulatory frameworks and air traffic management systems will need to be established. By 2030, we can expect the development of air traffic control systems specifically designed for low-altitude urban air mobility. This will involve integrating advanced technologies like AI and machine learning to manage the increased air traffic efficiently, ensuring safety and minimizing congestion. 3. Infrastructure development, vertiports and charging stations. The infrastructure to support flying cars will evolve rapidly. Expect to see the establishment of vertiports, dedicated takeoff and landing zones for eVTOLs, across major cities. These vertiports will be strategically located near public transport hubs and urban centers, providing seamless integration into existing transportation networks. Additionally, charging stations for eVTOLs will be built to accommodate the rapid growth in electric aircraft, ensuring that these vehicles can operate efficiently. 4. Integration with smart city concepts. Flying cars will play a crucial role in the development of smart cities. By 2030, urban planners will design cities with integrated transportation systems that include flying cars as a key component. This integration will enable efficient movement of people and goods, reducing road congestion and travel times. Smart traffic management systems will coordinate flying car operations, optimizing routes and enhancing overall urban mobility. 5. Increased safety through automation and AI. The implementation of autonomous flying technology will significantly enhance safety. By 2030, many flying cars are expected to be equipped with advanced AI systems capable of piloting the vehicle without human intervention. This technology will reduce the likelihood of accidents caused by human error, making flying cars a safer alternative to traditional road vehicles. Furthermore, real-time monitoring and data analytics will ensure that safety measures are continuously improved. 6. Environmental impact and sustainability. With growing concerns about climate change, flying cars will likely prioritize sustainability. By 2030, the majority of flying cars will be electric, utilizing renewable energy sources for charging. As battery technology continues to advance, we can expect to see increased range and efficiency, making flying cars an environmentally friendly alternative to conventional vehicles. This shift will align with global efforts to reduce carbon emissions and promote sustainable urban development. 7. Economic opportunities and job creation. The emergence of flying cars will create new economic opportunities, particularly in sectors such as aerospace engineering, urban planning, and transportation services. By 2030, we can expect to see a burgeoning industry focused on the development, manufacturing, and maintenance of flying cars. This will lead to job creation in various fields, from technical positions to regulatory compliance and customer service roles. 8. Public perception and social acceptance. The acceptance of flying cars within society will be crucial for their success. By 2030, public perception is expected to shift positively as people become more familiar with the technology and its benefits. Safety improvements, successful pilot programs, and positive media coverage will contribute to a growing acceptance of flying cars as a legitimate mode of transportation. However, addressing concerns about noise pollution and privacy will be essential to ensure widespread adoption. 9. Global expansion and accessibility. Initially, flying cars will be introduced in major urban centers, but by 2030 we can anticipate their expansion into suburban and rural areas. The accessibility of flying cars will be enhanced through partnerships with ride-sharing platforms and public transportation systems, making air travel more affordable and available to a broader segment of the population. Conclusion. The future of flying cars is poised to revolutionize transportation as we know it. With advancements in technology, regulatory frameworks, and infrastructure development, we are on the cusp of a new era that will redefine urban mobility. By 2030, flying cars will not only be a reality but will also play a pivotal role in creating smarter, more sustainable cities. As we embrace this future, it is essential to continue addressing the challenges and concerns that arise, ensuring that the dream of flying cars becomes a safe, efficient, and accessible part of everyday life.